Well, these are some past paper questions for Poisson distribution, and these questions are extracted from Cambridge A-Level Statistics 2 past papers. So the first question is, particles are emitted randomly from a radioactive substance at a constant rate of 3.6 per minute. Find the probability that more than 3 particles are emitted during a 20-second period. So firstly, I will answer the first part of this question. And when you look into this question, the first thing that I consider here is the unit interval. Because in the question, the average is given for 1 minute. But the first part of the question refers to 20-second period. I will use a bit of proportions. So 1 minute it's 3.6 particles, 20 seconds it's 1.2 particles. 3.6 divided by 60 multiplied by 20. So I can write the information as X is Poissonly distributed with lambda 1.2. And the question is the probability of X greater than 3. More than 3 particles means it is X greater than 3. So it should start with 4 because it is greater than 3. 3 is not there. That means you have to begin with 4. So you have to begin with 4, 5, 6 and so on. So you don't know what is the end X value for you to find the probability. So the easiest way of doing this question is you find the probability of X equals to 0, X equals to 1, X equals to 2 and X equals to 3 and you subtract it from the total probability which is 1. You know, in this sum, when they say the probability of X greater than 3, that means it begins with 4, right? Greater than 3 means it should begins with 4. So if it is to begin with 4, you have to end the probabilities with 3. That means X equals to 0. The probability of X equals to 0 you can find using this. The probability of X equals to 1 you can find using this. And the probability of X equals to 2 you can find using this. And the probability of X equals to 3 you can find using this. So you add all these 3 probabilities. Actually, you have to add all these 4 probabilities and you subtract it from 1. So you get the probability of X greater than 3 as 0.034. Second part of this question is the probability of more than 240 particles are emitted during a 1 hour period. Now you can see here 240 particles emitted in 1 hour period. So you can see the X value is a large value here. It's more than 240. Also the unit interval you have to convert 3.6 per minute multiplied by 60 for 1 hour, which lambda is equal to 260. So as we know, if we have a large value of X as well as a large lambda average value, we are going to use normal approximation. That means the normal distribution is being used as an approximation for Poisson distribution. So you know that when we use a continuous distribution to approximate the discrete distribution, we have to concern the continuity correction. So they say here X is greater than 240. You have to find the probability of X greater than 240. And you can clearly see the value 240 is excluded. So we don't need 240. We need a value which is more than 240. According to continuity correction, we are going to add 0.5 because we're not going to take 240. Okay, so 240 is excluded. Therefore, we are going to add 0.5. So we are going to find the probability of X being greater than 240.5. Since we are using normal distribution, we have to write the parameters of normal distribution, which X is normally distributed with mu comma sigma squared, where mu and sigma squared are the two parameters of normal distribution. So we know, according to the previous presentations which I explained you, that the mu and the sigma squared of the Poisson distribution is same as the lambda value. So here lambda is equal to 216, mu is equal to 216, as well as sigma squared is also equal to 216, the same lambda value, and we can write it as x is normally distributed with 216, 216. Okay, so here is the graphical presentation of probability of x being greater than 240.5. I have shaded it in red, and we know how to use normal distribution formulas, that is z equals to x minus mu over sigma. Here the x value is 240.5 according to the previous slide, and mu is 216, which is same as the lambda value. You divide it by sigma. Sigma means the standard deviation. So the standard deviation is square root 216. So z value is 1.667. You use this normal distribution tables to find the probability. So the probability that is relevant for 1.67 is this particular probability from here to here, because the tables gives you the probabilities from left to right. So this probability is 0.9522. But the relevant probability is what is shaded in red, because according to the question, it is the probability of x is greater than 240.5. So we are going to subtract it from 1, because the area under the curve is 1. Total probability is 1. 1 minus 0.9522 is 0.0478. So the probability of x being greater than 240.5 is 0.0478, which is shaded in red. Second question. The number of calls received per 5-minute period at a large call center has a Poisson distribution with mean lambda, where lambda is greater than 30. If more than 55 calls are received in a 5-minute period, the call center is overloaded. It has been found that the probability of being overloaded during a randomly chosen 5-minute period is 0.01. Use the normal approximation to the Poisson distribution to obtain a quadratic equation in square root of lambda, and hence find the value of lambda. Look at this question. Average calls per 5-minute period is equal to lambda, and the possibility of receiving more than 55 calls in 5 minutes period is set as 0.01. So we can write it as probability of call center being overloaded. So when is the call center is overloaded? If you receive more than 55 calls in 5-minute period. So that probability is 0.01. And the question says to use normal approximation. Because we are using normal approximation, we have to use the continuity correction. So we can say it is it is more than 55. So when it is more than 55, 55 is excluded. So if excluding 55, we are going to add 0.5. So we are going to start with 55.5. So x is normally distributed with mu comma sigma square. We know that mu is equal to lambda, as well as sigma square is equal to lambda. So we are going to use the normal distribution to approximate the Poisson distribution. So z is equal to x minus mu over sigma. X is 55.5. Mu and sigma, the two values we don't know. And what we have to find is the probability of x being greater than 55.5 and the sum gives you the probability. So x being greater than 55.5 is equal to 0.01. So we know how to use the normal distribution tables. We have to find the z value that gives you a probability of 0.99, because in the normal distribution tables the probabilities are given from left to right. So we have to take the readings which covers up a probability of 0.99. So the z value which covers up a probability of 0.99 is 2.326. So we know the z value, we can substitute it into the previous formula, that is 2.326 equals to x is 55.5 minus mu divided by sigma. We know that mu and sigma squared is the same as lambda. So we can use those two values. 2.326 is equal to 55.5 minus mu is equal to lambda, divided by square root of lambda. Using a bit of algebra, you can finally write the equation as lambda plus 2.326 square root of lambda minus 55.5 equals to 0. Now it takes the quadratic nature. It's a quadratic equation now. So either you can use the calculator to solve the quadratic equation, or you can use the formula, that is x equals to minus b plus or minus square root of b squared minus 4ac over 2a to solve the value for x. We have to take that x is equal to square root of lambda. So we can rewrite the given equation as x squared plus 2.326x minus 55.5 is equal to 0. It's easy to use the calculator and to get the answer. If not, you better write the values to the formula and show the answers. So your lambda value is lambda is equal to 40.7. This last part is all about your pure maths. It's just a bit of algebra simplifications. So you can follow it up. This is another sum. This is also another past paper question. The number of calls received at a small call center has a Poisson distribution with mean 2.4 calls per 5-minute period. Find the probability of exactly 4 calls in an 8-minute period, at least 3 calls in a 3-minute period. And the next part is the number of calls received at a large call center has a Poisson distribution with mean 41 calls per 5-minute period. So it's a large mean there. And the sum itself says to use an approximation distribution to find the probability that the number of calls received in a 5-minute period is between 41 and 59 inclusive. I'm not going to work out this sum. I will give you the marking scheme answer. And I will highlight some important points that you have to consider when you're doing part 1. That is, you have to convert 2.4 for 5 minutes and the average calls for 8 minutes. And exactly 4 calls means the probability of x is equal to 0. So that is the important fact for the first part. Second part, at least 3 calls, that means minimum 3 or more. It says x is greater than or equal to 3. So how are you going to find the probabilities for x is greater than or equal to 3? You don't know when it is greater than or equal to 3. 3 is the minimum value, the starting value, and it should go until which value? You don't know that. So therefore again we are going to use that 1 minus thing. So you have to subtract the probabilities of x equals to 0, x equals to 1 and x equals to 2 only. X equals to 0, x equals to 1 and x equals to 2 only. At least 3 says it should include 3 or more. So for you to find the probability of x being greater than or equal to 3, you subtract from 1 x equals 0, 1, 2 only. So as well as again the unit interval is considered for 3-minute period in part 2. And the next one, it says it's a large call center. So you have to use the approximation distribution, that is the normal distribution, and you have to find out the parameters of the normal distribution. So, and it is also the probability you have to find between 41 and 59 inclusively. So you have to find out the probability of x being greater than or equal to 41, less than or equal to 59. You have to use the knowledge of normal distribution for you to find the relevant probability between 41 and 59 over here. So try this question. The answer is there according to the marking scheme. This is the marking scheme. And let's see whether there are more questions which I could discuss with you in my next presentations.